Welcome students. This is the continuation of optics chapter. In this class we are going to learn about lens formula, sign convention, lens maker's formula and power of a lens. So first we are going to learn about lens formula. So we have lens formula for spherical lenses. So this is the lens formula. It relates the object distance, image distance and focal length. So we know object distance is denoted by the letter U, that is the distance between the optical center and the object. So the distance between the optical center and the object is known as object distance, that is denoted by the letter U. Next, image distance, the distance between the optical center and the image. This is image distance, that is denoted by the letter V. Then F, it is the distance between optical center and the principal focus. So it is denoted by the letter F. So object distance U, image distance V and focal length F. So lens formula is 1 by F is equal to 1 by V minus 1 by U. So this lens formula relates focal length, image distance and object distance. It is applicable to both convex and concave lenses. Next, sign convention. So Cartesian sign conventions are used for measuring various distances in ray diagram of spherical lenses. So these sign conventions are used for measuring various distances in a ray diagram for optical lenses. So there are 6 conventions are there. So first one, the object is always placed on the left side of the lens. So we know that when we draw the ray diagram, the object is placed on the left side of the lens. So this is the first convention, that is the object is always placed on the left side of the lens. Next one, all the distances are measured from the optical center of the lens. So we know optical center. So all the distances are measured from the optical center of the lens. So next one, the distance is measured in the same direction as that of the incident light are taken as positive. The distances in the same direction as that of the incident light are taken as positive. Next, the distances measured opposite direction, in the opposite direction of the incident light are taken as negative. So likewise, next distances are measured upward, that is perpendicular to the principal axis, taken as positive. Next, distances measured downward, that is perpendicular to the principal axis, taken as negative. So these are the important Cartesian sign conventions that is used for measuring various distances when we draw the ray diagram. So see here, spherical lenses are placed. So first convention, the object is always placed on the left side of the lens. Then this is the optical center. All the distances are measured from the optical center. So third convention, the distances measured in the direction of the incident light. So this is the direction of the incident light. So the distances measured in the direction of incident ray are taken as positive. Next one, the distances measured in the opposite direction of the incident light. So this is the direction of incident light. So the opposite direction is here. So the distances measured in this area are taken as negative. Next one, the distances measured upward, that is perpendicular to the principal axis, are taken as positive. Next, the distances measured downward, that is also perpendicular to the principal axis, are taken as negative. Next, magnification of a lens. So we have magnification for spherical lenses. So spherical lenses produce magnification, and it is defined as the ratio of height of the image to the height of the object. So consider height of the image is h dash, then height of the object is h. So magnification is ratio of height of the image h dash to the height of the object h. So magnification is denoted by the letter m, small m. So m is equal to h dash by h. Then it is also related to the distance of the image and the distance of the object. So we know distance of the image is denoted by the letter v, then distance of the object is u. So magnification is v by u, m is equal to v by u. So here height of the image h dash, then height of the object h. So it is the ratio, that is magnification is defined as the ratio between the height of the image to height of the object, that is h dash by h. If the magnification is greater than 1, we get an enlarged image. If magnification is less than 1, we get a diminished image. So when it is greater than 1, we get an enlarged image. When it is less than 1, we get a diminished image. So next, lens maker's formula. So this is the equation, this is lens maker's formula. So all lenses are made up of transparent material. So all the transparent medium have refractive index, that is mu. So the lens formula relates the focal length of the lens, refractive index of the lens. Then here R1, R2 is the radius of curvature, that is radius of curvature of the lenses. So this equation relates the radius of curvature of two faces of lenses and refractive index of the given material of lens, then focal length of the lens. So this is the lens maker's formula equation. So next, power of a lens. So when a light ray falls on a lens, the ability of lens to converge or diverge the light rays depends on focal length. So ability of lenses to converge or diverge the light rays that is fall on the lens depends on focal length, that is f. So power of a lens is defined as ability of a lens to converge or diverge is called its power. So here P is equal to 1 by F. So this is the numerically, it is expressed in numerically. The next, power of a lens can be defined as a degree of convergence or divergence of light. So P is equal to 1 by F. So here F is the focal length. So reciprocal of focal length. Power of a lens is reciprocal of its focal length, that is 1 by F. So next, SI unit of power is diopter, denoted by the letter capital D. Then unit of focal length is meter, that is small m. So if 1 diopter is the power of a lens whose focal length is 1 meter. So we know the formula P is equal to 1 by F, that is power is equal to 1 by focal length. So if the power of a lens is 1 diopter, mean its focal length is 1 meter. So here by convention the power of a convex lens is taken as positive, then power of a concave lens is taken as negative. So this is the mathematical expression of power of a lens, that is P is equal to 1 by F. So SI unit of power is diopter, then SI unit of focal length is meter. So next we are going to learn about the basic difference between convex lens and concave lens. So we know that a convex lens is thicker in the middle than at edges. A concave lens is thinner in the middle than at edges. So next one, convex lens converges the light rays, so it is a converging lens. Concave diverges the light rays, that is falling on the lens, so it is a diverging lens. So next one, convex lens produces mostly real images. That is, real image can be caught on the screen. But in concave, it produces mostly virtual images. So virtual images cannot be caught on the screen, cannot be obtained on screen. So next one, it is used to treat myopia. Convex lens is used to treat the defect of vision, that is myopia. Myopia is also known as short-sightedness. Concave lens is used to treat hypermetropia. So it is also a defect of vision, that is long-sightedness. So concave lens is used to correct the defect of vision, that is hypermetropia. Convex lens is used to correct the defect of vision, myopia. So these are the basic differences between convex and concave lens. So convex lens is thicker in the middle, concave lens is thinner in the middle. It is a converging lens, then concave lens is diverging lens. Convex lens produces mostly real images, concave lens produces mostly virtual images. Then convex lens is used to treat myopia, concave lens is used to treat hypermetropia. So students, hope you all understood about lens formula, sign convention, lens makers formula, power of a lens, and the difference between convex and concave lenses. Thank you.